Now I am going to explain ammeter. At the end of this session, you will be able to understand the operation of the ammeter and know the types of different ammeters. Actually, what is ammeter? Ammeter means ampere meter, which measures the ampere value. Ampere means it will be the units for the current. We have different types of ammeters. Right? Depending on the constructing principle, there are many types of ammeters. They are mainly classified into permanent magnetic moving coil ammeter, that is PMMC ammeter. This is the PMMC, permanent moving magnetic coil principle. Right. The second one is moving iron ammeter, which is calling as a MI ammeter. And the third one is electrodynamic ammeter. And fourth one is rectifier type ammeter. And one more is inductive type ammeter is also there. Right. This is the figure for the ammeter, which will be used for finding out the currents. This is the milliammeter. Okay, negative terminal is connected for this point and positive terminal will be connected for this point. The internal structure, internal operation, we will discuss. Different constructions we are using. Right. So, depending on the various classification of ammeter, we have DC ammeters as well as AC ammeters. Okay, in the DC ammeter as well as AC ammeter, we are using different type. That is a permanent magnetic moving coil or moving iron type. Different types of construction we are using in a DC ammeter. Different type of construction we are using AC ammeter. In DC ammeters are mainly permanent magnetic moving coil ammeter. Okay, the AC ammeters are, the DC ammeters are mainly used PMMC instruments. And moving iron can be measured both AC as well as a DC currents. And electrodynamic type ammeter, thermal instrument, can measure DC as well as a AC currents. Okay, in moving iron as well as electrodynamic meter type ammeters can use to measure the AC currents as well as a DC currents. Whereas in PMMC instrument, only it is used to measure the current DC currents only. And induction meters are not generally used for ammeter construction due to their high cost. Induction is the cost will be high. That's why it is not used. Okay. So the construction of DC ammeter. This is the construction of DC ammeter. Here we are using B-Arsenal moment meter, that is a galvanometer. Here we are using a galvanometer. The RSH resistance, that is the shunt resistance, is connected parallel with this one. This will the shunt current will be flown through this resistance. It will controls the flow of current. Right here, so you see this one. Current is the rate of flow of electromagnetic change. Sorry, rate of flow of electric change. If this electric charge flow only in one direction, then the resultant current is called direct current or DC current. Okay, the instrument which is used to measure the direct current, which is calling as a DC ammeter. Okay, firstly, the current is a flow of electric charge. It required one instrument to measure that current. Okay, that will be calling as a DC ammeter. Okay, if the charge is flows only one direction, that will be calling as a direct current. That current will be measured by using a DC ammeter. If we place a resistor in parallel with the permanent magnet moving coil, that is a PMMC galvanometer. It is the PMMC galvanometer. Here it is the PMMC galvanometer. Then the entire combination acts as a DC ammeter. The parallel resistance which is used in a DC ammeter is also called as a shunt resistance or supply resistance. This one. This RSH is calling as a shunt resistance or supply resistance, which is connected in parallel with the galvanometer. The value of this resistance should be considered small in order to measure DC current of a large value. If the resistance is high, the current will be less. That's why always we have to choose RSHS will be a lesser value. And these are the DC ammeter. How to finding out RHS value? How to we can finding the RHS value? This already we know the ISH. ISH is the current flown through the shunt resistance, which is indicated here. This is ISH. That ISH into RSH will give some voltage, and IM into RM. The internal resistance of the galvanometer will be RM. So this RM into the current flown through this one will be the IM, will give the voltage. This voltage across RSH and this voltage is equal. Why? Because these two are in parallel. These two are in parallel. That's why the voltage across these two will be equal. That's why here ISH into RSH is equals to IM into RF. From this one, we want to calculate RSH, shunt resistance. The shunt resistance is equals to IM RM divided by ISH. Actually, what is ISH? This is the I is the total current. This will be divided into ISH as well as a IM. Okay. So then ISH is subtract from the total current. So I minus IM. Right. Now replace ISH with the value of I minus IM. Then RSH is equals to IM into RM divided by I minus IM. This is the value of RSH. Okay. So already we know the notation of this one. RHS is the shunt resistance. RM is the internal resistance of the galvanometer. This one RM, and I is the total direct current that to be measured. This will be the I, total current. Okay, this is RM, internal resistance. This will be the shunt resistance. This will be the shunt current, ISH, and IM is the full scale deflection current on the galvanometer. Okay. So previously we have discussed the single range voltmeter. This will be used for finding out a single range. You see this, ammeter. This will be measured up to 100 milliamps only. Okay. By using multi-range ammeter, we can measure different ranges of currents. Okay. We can use different ranges of currents with the principle of basic ammeter. That is the shunt resistance with galvanometer. The shunt resistance is connected parallelly with the galvanometer, and here we have different resistances connected parallelly. Here we have different resistance are connected parallelly, and we are arranging one switch here. If switch is connected to this resistance, it will give this range of current. Okay. If you increase in the range of the current, you have to connect this switch to this one, this resistance. If you again increase this one, the value, you can connect this switch to this point. Okay, it will give some range of current. Okay, so if you connect this switch to this one, it will give one more range. If you connect this switch to this switch to this one, it will give one more range. That's why it is calling as multi-range DC ammeter. The range of DC ammeter can be extended by number of shunts selected by a range switch. The switch S is a multi-position switch. Okay, so it has 4 shunts from this figure. That is RSH1, SH2, RSH2, SH3, RHS, SH4, which can be placed in parallel with the movement to give 4 different current ranges. Okay, this one is called multi-range DC ammeter. Okay, the one more type is thermocouple type RF ammeter. In this type, we are using 2 types of coupling wires. One is calling as a heater. The one more is calling as a thermocoupler. Okay, both are different materials. Okay, this wired material is a different. This wired material is different. Okay. So, and this one is connected in parallel with the galvanometer. That is the PMMC instrument. Okay, so it has 2 different metals which are placed in contact with each other. First part is called heating element, that is a heater. First part is calling as a heater. See this one. This one is calling as a heater. And when the current will be flown, through this, a heat will be produced, and thus the temperature will be increased at the junction. At this junction, a EMF will be produced, which is proportional to the temperature difference between the hot and cold junction. The temperature between the hot and cold junction. This one will be the hot junction. This one will be the cold junction. This is the cold junction. This is the hot junction. The temperature difference will be produced when current is applied through the heater will be heats up. This is the cold junction. There will be a difference between the temperature. That will be calling as a EMF. The EMF produced is a DC voltage, which is directionally proportional to root mean square value of the electric current, which is what type of current we are connecting to these wires. That will be proportional to the EMF, right? So the thermocouple type instrument can be used for measuring the AC as well as DC currents. Also, thermal type of instruments has greater accuracy. It will be having greater accuracy compared to the PMMC, compared to the previous circuits in measuring the current and as well as the voltages at a higher frequency accurately. That's why the thermocouple type ammeters are used in the RF range, that is the radio frequency ranges. That's why it is calling as thermocouple type RF ammeters. Right, we have different types of thermocouples. Okay, the first one is mutual type thermocouple, and the second one is contact type thermocouple, the mutual type thermocouple. This is the mutual type thermocouple, and the second one is contact type thermocouple. The third one is separate type separate heater type thermocouple, and the fourth one is bridge type thermocouple. Okay, so this is the mutual type thermocouple. This is the contact type thermocouple. Here it is the separate heater type thermocouple, and this will be the bridge type thermocouple. Okay, we will discuss one by one, right? So the first one is the mutual type thermocouple. Right, here the mutual type thermocouple, the current passed through the thermocouple itself and not through heater wire. Here we are not using any heater wires. Directly we are sending the current to the thermocouple. So it has a disadvantage that meter shunts the thermocouple. Okay, the heat will be directly goes to the thermocouple. That will be the disadvantage in mutual type. The second one is contact type thermocouple. This is the contact type thermocouple. In this, right, contact type, this is the this is the contact type thermocouple. In this, there are separate thermocouple leads which conduct away the heater from heat wire. It is having less sensitivity. Here we are applying the current through to this wire. It will heats up. Okay, so the thermocouple is directly connected to the this heater, this B terminal. Okay, this is the A terminal, this is the C, and this is the B point. Okay, the thermocouple is directly contact to the heater. Okay, based on the heat, the EMF will be produced. Based on that one, the galvanometer will be changes. Okay, based on the changes in the current applied to the heater, we will measuring the current value. So it is less sensitive than the mutual type. Why? Because the sensitivity is less. Why? Because we are using separate thermocouples, the separate elements. Right? One is a heater, another one is thermocouple element. Right? The separate heater type. Here we are using glass bead in between the thermocouple as well as a heater element. Okay, whenever you applying the current through this heater element, this will be heated up. EMF will be produced. That will be goes through the glass bead to the thermocouple. Right. So here we are using an insulator. So some of the EMF, some of the heat will be evaporated, and the losses will be occurred in this one. So in this thermocouple is held near the heater but insulated from it by a glass bead. It has less sensitivity due to temperature drop in glass bead. It uses for RF current measurement. To avoid the losses of the heat by radiation, this arrangement can be placed in the vacuum tube. It increases the sensitivity. If you place the total system in the vacuum tube, it will increase the sensitivity. The fourth one is bridge type thermocouple. Bridge type thermocouple. Here 4 thermocouples we are using. 1, 2, 3, and 4 thermocouples we are using in the form of bridge. And the instrument, that is the galvanometer PMMC instrument, is connected in between these 2 terminals. Okay, in this one, the sensitive, there is no insulator, there is no direct connectivity to the PMMC instrument. That's why the sensitivity will be increases. Okay, mainly different types of materials are used in the thermocouples. That is constant or manganese elements are used. Constant and manganese elements are used for the thermocouple. So these are some glossaries. Thermocouple means is a sensor that measures the temperature. A rectifier means convert the AC to DC signal. The next topic is ammeters. The sample short answer questions is how the range of DC ammeter is extended. The sample long answer question is describe the operation of thermocouple type RF ammeter. Thank you.